Today we're going to talk about the distributive property and multiplying polynomials. So once again, a polynomial is many terms put together by adding or subtracting them. So when we distribute the term in front of the parenthesis, we distribute that term to all the terms inside of the parenthesis. So whenever there's a number in front of a parenthesis, you can take that number all the way through to every term inside the parenthesis. So some examples here would be 7 times negative 5e minus 8. So we just need to take the 7 to each term here. So we have 7 times negative 5, which is 35, negative 35v. We have 7 times negative 8, which is negative 56. So that's all we need to do for these problems. So for this one here, once again, we just need to take this negative 4 to each thing. So negative 4 times v is negative 4v. And negative 4 times 1 is negative 4. For the bottom, we need to take this whole thing through, the 6 and the v through. So 6v goes to each term here. So 6v times 2v is 12v squared. Now this is because there's an exponent of 1 here on this v and an exponent of 1 on this v here. So when you add exponents, you get 2 because we are using the product rule because we're multiplying. And then here we have 6v times 3, which is just 18v. For this one here, once again, we just distribute this through, and we get 4x cubed, negative 4x cubed, sorry, and negative 6x squared. So we're just simply multiplying this term to everything inside the parenthesis. So, multiplying polynomials. When we multiply polynomials, there are a couple methods we can use. We can use the box method, or we can use the FOIL or distributive method. So I'm going to start out with the box method. And when we use the box method, we just need to rewrite these terms to match up with these boxes. So I'm going to write the 2n plus 2 right here, and 6n plus 1 right here. Okay? So now, in this box here, we're just going to multiply the numbers that correspond to this box. So we have 6n times 2n, which is 12n squared. Alright, and for this box here, we have 6n times 2, which is 12n. And for this one down here, we have 2n times 1, which is just 2n. And then for this last box, we have 2 times 1, which is 2. Now we need to collect like terms here. Okay, our like terms are always going to be diagonal from each other. So 12n squared plus 12n plus 2n, which is 14n plus 2. So we're going to save the over here. 4a plus 2, 6a squared minus a. Make sure you take that minus with that a, plus 2. So once again, we're going to multiply these together. So we get 24a cubed minus 4a squared plus 8a. This is 12a squared minus 2a and 4. So once again, collect like terms for diagonals. Okay, so we have 24a cubed plus 8a squared plus 6a plus 4. And that's our final answer. Alright, so now we have the distributive or FOIL method. So FOIL means first, outside, inside, last. Alright, so generally what FOIL looks like is something like this. We have our first term, our outside term, our last term, our inside term, sorry, and then our last term. Which really is the same thing as this, just in a different way. Same thing. Distributive and FOIL are basically the same thing. So here I'm going to FOIL these. So I have first, which is 12x squared, outside, which is 9x, inside, which is negative 16x. I'm writing these on top of each other just because they're like terms, and we're going to have to collect like terms in the end. And our last term is negative 12. So negative 12x squared minus 7x minus 12. So all we just got to do is collect like terms right here. Once again, I'm going to FOIL this. So first I get x squared, outside I get plus 4x, inside I get negative 4x, and our last term I get negative 16. Okay, so collect like terms, those go away, and we get x squared minus 16. Once again, first term you get 48n squared. Outside we get negative 24n. Inside we get positive 6n, and our last we get negative 3. So we have 48n squared minus 18n minus 3. And for this one, we get 30k squared plus 30k plus 25k plus 25. So we have 30k squared plus 55k plus 25. Okay, so this is a FOIL method. Pretty simple, just remember first, outside, inside, last. So for these here, you can use the distributive method or you can use the box method. For the first one I'm going to use the box method. For the second one I'll use the distributive method. Now you cannot use the FOIL method on these because we have more than 2 terms in one of our polynomials. So we can't use the FOIL method. So I'm just setting up my box here. Alright, now all we need to do is multiply all this through. So we have 7y cubed, 7y times negative 2y is negative 14y, 7y times 7 is 49y, y squared times negative 3 is negative 3y squared, negative 3 times negative 2y is 6y, and negative 3 times 7 is negative 21. So once again, collect like terms in our diagonals. We get 7y cubed, we get negative 3y squared and negative 4y squared, and we get negative 17y squared, and 49 plus 6 is 55y minus 21. So that's our final answer there. Okay, so now for this one here, I'm going to use the distributive property. So I'm going to distribute this x to each term. Okay, so we have x times x squared, which is x cubed. X times negative 5x is negative 5x squared. And x times 4 is 4x. Now we need to do the same thing to the 2. So we're going to have 2 times x squared. So we have 2x squared. And we have 2 times negative 5x, which is negative 10x, and 2 times 4, which is 8. Okay, so collect like terms here. We get x cubed minus 3x squared minus 6x plus 8. For these, you're going to do the same type of thing. But for time's sake, I'm not going to go over them, so you can try them on your own. And if you want to know what the correct answers are, just go onto my website and look at the notes filled out, and they will be on there. So when we square a polynomial, there should be an exponent of 2 here. When we square a polynomial, all we need to do is we need to write the first term, or our first term, we square our first term. So here a is our first term. So this will be squared. For the second term, we need to multiply these by each other. So when we multiply a times b, we get ab, and then multiply it by 2, so we get 2ab. And then our last term, we just square it, so we get b squared. We can also look at this as a plus b times a plus b. Just like saying 2 squared is 2 times 2, a plus b squared is a plus b times a plus b. And then you can just FOIL it and you'll end up with something that looks like this. So here we have x minus 6 times x minus 6. Okay, it's another way we can look at it. So let's FOIL this. When we FOIL this, we get first, which is x squared, last, which is negative 6x, or outside, sorry, outside is negative 6x, inside is negative 6x, and last is positive 36. So we get x squared minus 12x plus 36. Okay, now if we look at this and see, well, if we square our first term, x, we get x squared. Now, if we multiply our two terms together, we get negative 6x. Okay, when we multiply these together. So if you take negative 6x and multiply it by 2, you get negative 12x. And if we take our last term here and square that, we get 36. So that's where our a squared plus 2ab plus b squared formula came from. So we square the first, multiply our first and second together, and then multiply by 2, and then square our last. So once again, I'm going to square the first, okay, square this, so negative 2x squared is 4x squared. Multiply these by each other, so we have negative 2x times negative 3, which is positive 6x. So now take positive 6x times 2, which is positive 12x. And then we just need to square our last term. So negative 3 squared is 9. So then this is our final answer. You can also write it out like this, and then FOIL it if you want. So here, I'll write this one out. So we have our first term, which is 9x squared. Our outside term, which is 27x. Inside term, which is 27x. And our last term, which is 81. So we have 9x squared plus 54x plus 81. Also on this one, you do the same thing. So I'm going to square my first term, so 4n times 4n is 16n squared. Multiply these together, so 4n times 6 is 24n. Multiply that by 2, you get 48n. And square our last term. So here's our final answer. Now, I have some story problems here, but due to time, I'm not going to go through the story problems. If you look on the notes online, the story problems are up there on the notes that are filled out. If you want to go through these story problems, go ahead and go through them. And if you have questions on them, please ask me during class, before or after, and I'll be glad to help you. So if you want to do these story problems, go for it. I highly encourage you to do them, and then check your answers with what's online.